All right. Good morning, everyone, or good afternoon, or good evening, depending on where you are tuning in from. My name is Brian Mongkolpoonsuk, Customer Success Manager here at KETIV Technologies. And this is KETIV Virtual Academy, free weekly webinars to educate the community on technology workflow, brought to you by KETIV Technologies, of course. And today I'm excited to go over 3D printing in Fusion 360 with the new Snap Fit features inside the product design extension. And quote unquote new, it's been out for a little bit already, but new to me. I'm just diving into it, and definitely got a lot of experience now to share with you guys of what what the 3D printing side of it has done for me. And I wanted to see if it actually worked or not, because the Snap Fit is actually intended for plastic injection molding as opposed to 3D printing. So I was curious to see if what if you're a hobbyist, or someone who has a 3D printer and doesn't have access to plastic injection molding, are you able to utilize this for yourself? So that's going to be the whole purpose of this webinar, is to go dive into the product design. It is an extension inside of Fusion 360, so it would be an additional cost, but to dive into this tool and then see, through an experience of someone like myself, what the results were. So quick agenda for today. There are 3 different types of Snap Fit solutions that we'll be diving into. I printed 2 of the 3. And then there's also the Boss feature with ribs. So that's for screws essentially to go into that. And I printed that out as well. And we're going to hold questions actually till the end of the presentation today, just because when this does go on YouTube, I just want the people referring to this on YouTube just to go straight through it without having to go through any random questions. KETIV, I help with the adoption of the tools and services we provide customers. As you can tell, I'm a 3D printing enthusiast. I love 3D printing, have about 5 printers at home myself. And I am the coach of the KETIV softball team that we have here in Orange County, California. So if you ever are nearby, definitely stop by and watch our softball games. Slow pitch softball. All right, let's go ahead and dive into it. 3 types of Snap Fit solutions. There's the parallel hook and groove, perpendicular hook and groove, and hook and loop. So the parallel hook and groove, couldn't find an example in time. This is what it's going to look like, where you have the ability to push and pull bidirectionally for the Snap Fit itself. And I'll be showing kind of like a visual of that. But as you can see here, if you apply enough pressure, the nice thing about plastics is you're able to bend it, right? So if you apply enough pressure going in the down to up direction, it will apply pressure to this part of the plastic there, and then it will bend the hook back, and then it will snap into place. And vice versa, when you're pulling it down, then it will apply pressure to this part of the hook there, and then it'll snap off. So that's the whole purpose and logic behind Snap Fits, is the ability for the plastics to bend and snap into under a certain amount of force. So that's the parallel hook and groove. The perpendicular hook and groove, one example that I thought I could relate to way back when was the like child lock for cabinets or doors, where essentially you are closing this cabinet, but it's hard to open if you're just pulling directly back out because of this perpendicular. It doesn't give you an angle there, this perpendicular kind of lock holding it back, the mechanism. And the only way to really release this door is to apply pressure to where it's circular there, and then the spring will absorb that, and then it'll go down, so then it releases it to go through. So that's like a one-way street for a Snap Fit solution. And lastly, we have the hook and loop. Something that came to mind was the pencil box from way back when as well. So essentially, if you take a look here, the loop goes around the hook. I like to call it a little nudge that comes out, but it's a little bits of plastic in the middle that's surrounded by the lid part, the blue part. So it kind of just encompasses that. So as long as you apply pressure towards the bottom middle of the base there, you're able to unleash the hatch and then get whatever you need inside. So this is going to be some of the tips and best practices that we'll be going into. Maybe just use this as a point of reference. I'll be referring back to this, but now we're going to dive into Fusion 360, and we'll probably run across some of these tips and best practices. So here, my example for the parallel snap fit feature is going to be this playing card case that I created. It's about 2.5 by 3.5 inches. And essentially, it's going to be holding playing cards. I put a hole in the middle for 3D printing purposes, so it's less time to print. But we're going to be applying some snap fits to this. So let's first make sure we have the extension, which is this one right here, the product design extension. You could do it a day at a time. I think there might be yearly purchases for it. It's changing every so often, but you don't use cloud credits anymore. You use Flex tokens to purchase this. It's about $3 USD for one Flex token. And I think before I clicked to purchase this, this was about 4 cloud credits, or sorry, Flex tokens. And then if you look at this nesting and fabrication one, this one is about 11 cloud credits. So that would have been $33 per day. So my first tip is make sure you have your model ready to go, ready to be applied for the snap fit before even purchasing this extension, because then the time's ticking. Then you have to finish it within the day, within the 24 hours for your design, because you only have access to the snap fit tools during the time you purchase this, the 24 hours you purchase this. All right. So let's say I did, like in this case, I do have my design ready to go and complete. Then we're going to follow the golden rule of Fusion 360. There's actually like 2, which is like creating components right off the bat. But the other golden rule, which is working from left to right. So if we look at the top here, usually it starts in solid. We're going to go to plastic here. And now if you work from left to right, we're going to assign what is called a plastic rule. And if you ever heard of the sheet metal rules, that's where you can apply like thicknesses of your metal and K factors. This is a very similar concept. It's plastic rules where it tells you the thickness of it, but it can also give you things like draft angle, nominal radius, and whatever this knife edge threshold is. I am not an expert in the plastic rules myself, but I know enough to make changes to what we're about to do today. So with that said, let's go ahead and assign a plastic rule. I'll go ahead and assign it one of these ABSs if it's not already assigned already. There's a manage and assign. Let me just check here. Oh, sorry, I need to select the component here. And if you're confused, like I just was there, as to why or what to do next, this is super helpful. The information button at the bottom left-hand side, this is actually another tip of mine, just to go click on that, because it tells you what you need to do next or how to use the tool. So it says assign a plastic rule to a component, yada, yada, yada. In the browser, you can switch between plastic rules, yada, 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 more information, and then it'll open up a web browser with more deeper details on that. So what I need to do is select the component, and then I'll assign it the ABS plastic, which is the closest to PLA, which I actually used to print this out on. And now we have this plastic rule here under ABS, and it's going to follow anything in that ABS rule set. With that said, we can go to the next part, which is the snap fit tool. And here are the 3 options we have here: parallel hook, perpendicular hook, and hook and loop. And let me just hover over that so you can see the drop down. Again, just leave your mouse idle and you're able to access it. The only issue with this is you need to make sure to have a sketch. So right now I don't have a sketch that's active, so I can't select or create anything. So that's another tip, is to make sure you have a sketch. That's kind of not really a tip. It's more of a need, if you will. So I'm going to go ahead and create a sketch. I'll hide my top body there. And I'll create a sketch on this plane here, because that's where the point of reference for the snap fit hook is going to be. I will go ahead and hit L for line, and I can create a line tool just right in the middle there. And I'll hit finish sketch. And then if I go back to this snap fit tool, now I have some points, the end points of this line to create the feature on. And let me turn this body back on here so we can start to see a preview of what it's going to look like. And the nice thing about this visibility options here is it gives us transparency right off the bat. So if I turn these off, you can't really see clearly what's going on as much. But if we were to turn these on, the transparency, it's a lot more clear. So that's a relatively newer feature added to this extension. So if I were to add this and I could rotate it like 90 degrees or so it makes more sense here. I can add it so then the top part has this hook sticking out, or I can flip it around and have the bottom part with the hook sticking out. And if I hit OK there, we already have our thing created, our little hook that sticks out. And if I hide that body there, you can see it looks like that. And then the other part is just a little groove that goes in for the snap fit. And essentially, you can move the point of reference around. So if you don't like this sticking out like that, you can actually use the sketch and you can use points. You can take advantage of points to move that towards the center more. So essentially, if I go back to my sketch here, and I go to create a point, let's just put it more somewhere around there. And then I tell this snap fit to reference that sketch point instead of the endpoint. Let's see what it gives us here. So it completely is hidden inside. We can do a quick section analysis to see where it is. Let me use that point there. And it is hidden too far inside. So what you can do instead is you can move this sketch point maybe back more. And now you can start seeing it start to appear on the outside more. I don't think it updated properly because I think you have to create this after the fact. So let me delete that and just create a new one real quick. Snap fit, parallel hook, rotate that 90 degrees. And there we go. Now we have the cut in the model, and we can hide our sketch there to just make it look cleaner. All right. So I printed this out right off the bat after creating this, and I will go ahead and show you in real life. I'm going to stop my share here. And I will go ahead and show you the first print I did. Thank you, Zoe. Zoe's in the background helping me out here. You can see how small these little hooks are that are sticking out. It looked very fragile, but it works. So if I go here, I hope I don't break it on live here on the camera. I don't know if you can hear that, the mic, we have a mic right here. But now it's snap fit together with FDM 3D printed. And it takes a little bit more force to take it out, but it's a good amount of force. It's not too much, not too little, like a regular snap fit should be. So first attempt, it worked out. I was very happily surprised with that. I don't really need these holes here for leverage. But yeah, these can hold playing cards or what have you. But as long as the snap fit feature works, I'm happy with that. But I know since these hooks are so thin, we need to make that thicker. That's not something that's going to last long after like 100 uses. It's going to snap. It's going to snap. So let me go ahead and start sharing my screen again, and I can show you how to adjust that. So that's where the plastic rules come in. So if we go here to the plastic rules and hit manage, we can, or sorry, let me go here so you can get a better idea of it. So this hook and groove is defined by everything down below here. I didn't address any of this yet. So the big variable that stands out the most, that appears the most, is T1, and that is our thickness. And when I saw that first, I'm thinking, okay, I'm just going to go to parameters. And there's my T, but I can't change it in here. If I double click on that, it won't let me change my parameter there. It lets me change this other thickness custom variable that I made, but not this one right here. This was created through plastic rules. So the way to modify this is by going up here to manage plastic rules. I think it was this ABS. I need to go figure out why I have two ABSs here. And then if you have thickness here, right now it's at 1.5. If I change that to 3, it enlarged that. So now it's a more sturdy hook that comes out. So that's really nice. It's better than if you were to go back into the actual feature itself. I first tried going in here and changing, the D variable here, which is the base width, as it's saying there. Instead of multiplying by 2, I was trying to multiply by 12 to make it longer like that, which could work if that's what you want. But changing the T1 thickness made it not only longer sideways, but also in every other direction. So then it's just stronger as a whole and not very thin. So that's my tip to you, is to go back here. And if you want to make it more sturdy, especially because 3D printing is not as strong as plastic injection molding, definitely go into your plastic rules here and make the change there. And I'm not going to show too much of this part of it, but you can also set presets. So I have a custom preset there. You can set presets of different rules that you like. And this preset, once you create it and add it here, it could be accessed by other designs as well. All right, so that is the parallel hook. Now let's go ahead and dive into the perpendicular hook. So that example, as you may recall, is the child lock. But in this case, I will have if you hopped on the webinar, I think it was about 6 months ago, I had a box and I was showing a custom snap fit of a box that I had. And this one I drew manually, and I had to test this by actually printing this out by trial and error. Now that we have the snap fit tools inside of Fusion 360, I don't have to utilize this anymore. I mean, I did find a good fine line for it, but now I have something that's formal and out of the box. So you don't have to go through the testing of this. So for example, I'm going to have this box ready for you here. Don't disregard those arrows there. But this box here is just like the other one, but without any snap fit settings yet. So what we're going to go ahead and do in here is we're going to go back to that snap fit perpendicular hook and groove this time. And again, we're going to need a sketch. So let's go ahead and create a sketch for this. Hide the lid there. And we'll create another line in the middle here. And we'll create a point that I won't constrain to this line. If I put it at the midpoint here, it's going to create a constraint there. I'll just put it as an intersection point, so I have the flexibility to move it around. And now if I go ahead and add the snap fit functionality, it's saying, oh, I need to assign a plastic rule. So I'm going to go ahead and assign plastic rule. I forgot to do my left to right workflow. I'll make it this ABS and hit OK there. I think I need it for the base as well, because now this is a multi-component assembly. I'm going to have to probably do it to the base here as well. So let's go ahead and assign plastic rule to the base. Base component to select. I don't think I got it. I think, oh, there it is. It's already under it. Okay. So now let's go to the snap fit and perpendicular hook and groove. And it auto detect my point, which is really nice. Now, if I rotate this around, that's not really how I'd want it to look. I'd rather have it go the other way. And actually, I'd rather have it go down. So let's flip it down. But yeah, I'd rather have it go the other way. So let's flip it 180 degrees there. And unfortunately, so I actually was trying to run into this error, but there's no geometry as a result of this operation. So I got stumped on this for a little bit, but what it turns out to be is if I move this sketch point back, and look at that, I can move it back without even having to enter the sketch. I can go into the snap fit again, go back to my perpendicular hook, flip it. Now it's going in the way that I want it to, kind of like, if you can imagine that pencil box with the hook, kind of like that, coming down and locking. And then if I apply pressure to the part of the box right here, then it will help alleviate it to come out of the snap fit. So let's go ahead and just go with the settings that we have here. And it is going inside there too much, so you can't even see it again. So this is where that's why you want the sketch point to be a little flexible. So then what I want to do now is I want to go back into that sketch here in the timeline down below here. Let's move that up just a bit. And looks like it updated properly this time. Because the snap fit happened after my sketch down below here. And it is a little narrow, so I'm going to do the same thing, or actually I'm going to go to the base width factor here. I'll do a multiply by 12 just to make it wider there. And then if I do a section analysis on this, you can see that it is going to look like this. And when it comes down, let's see if I can, there we go. When it comes down, it's going to apply pressure at that point there. And then this thing will bend backwards out like that. Of course, you can imagine how snap fit works. And then it'll lock into place there. And now we have our snap fit and we're in business. The only issue that I still want to overcome is why it creates this long groove down below here. I'll just be playing around with that until I figure it out. But essentially, a quick and dirty way to overcome that is to just go ahead and create a sketch down below here and just extrude it up just to cover it up. But again, I'd rather figure out why it created that groove down below there, because it made my box look not as pretty. But there you go. That's our perpendicular snap fit. Not a child lock like you were hoping, but there's a box version of it. All right. So the next or last option is the hook and loop. The hook and loop option. So I'll go ahead and actually, sorry, let me stop sharing my screen real quick. I'm going to show the second print I made. Just because I have it, I just want to show you how it behaves and looks. So let me stop my share. Thank you, Zoe. Appreciate that. And here's the other box. It looks very similar, but this one has a long, more sturdy design to it after I learned my lesson from the first one. And this is of the perpendicular design, by the way. Just like we're doing on that yellow box there, but this one has two on the edges there. And if I put those together, it snap fits. And then it takes a little bit of pressure to pull it apart, but not too much, which is good. So again, pleasantly surprised by how that fits perfect. That fits right. And then, yeah, if you want to make it more hard to pull apart or easier to pull apart, you can change the settings in your snap fit feature. So let me go ahead and start my share again. Okay, last one. I'm not going to go through the whole process because it's the same thing over and over at this point. But essentially, let me suppress these features. And the hook feature, I suppressed them down below here. I've already done that already. It's going to look something like this. You're going to go through some sketches. You're going to go through some designs. And then you're going to get something like this. So it's going to be imagine the pencil box at this point. There's going to be a little nudge that comes out, or they call it a hook. And then there's going to be a loop that comes out, which is this part here. And yeah, this would be useful for a kind of like pencil box kind of design. In this case, I just created this on this because I already have this design. And again, it's starting to get repetitive, but this is the third option you have when going into it. And this was previously a smaller loop, but I went ahead and increased the size through my T1 thickness through the plastic wools. All right. So I went through a lot of these tips. There is one more thing we need to go into is boss and ribs. So I'll go ahead and go into that. But let me make sure I covered everything here. You need sketch points, go into the question mark, the I at the bottom left-hand corner. And also one more tip I just saw here on the screen is if you like, if it makes it easier for you, you can go ahead and apply some acrylic, clear, transparent, glass, whatever kind of a material to the model as well. If you just want that visual all the time, you might also have a display setting for wireframe mode, which is essentially like the same thing. So you can see kind of through it, hence the wireframe. So just to give you that option in case you're having trouble viewing your model properly. Let me undo that because I'm about to dive into something we need to see more clearly, which is the boss feature. So essentially, boss gives you the ability to connect your model via screws. So you're able to connect two parts that way instead of a snap fit. So this is a way more permanent. This is something that you're probably not taking apart every other day or a couple times a day. And it has ribs to add support. And a lot of people requested ribs to Autodesk. So they also have ribs, which are these fins here to help support the boss itself, for the screw. So essentially, let's just go ahead and dive into it. Like the other snap fit features, let me suppress these. We're going to need sketches. So I'm going to go ahead and hide that. Just going to go straight to P for project on my keyboard. And I'm going to go ahead and select these there to project. It only selects one for some reason, so I'll select the other one. And now I have these purple reference lines here and with the center points that I'm going to be using for my boss feature as a quick example. Then finish sketch, I'm going to be going into my boss feature here. And you can see how that's going to be looking in just a moment. Of course, this is going to cover up our card space for the cards to be in, but this is just the example I'm using. So as you can see here, here's the blue side of it where the threads would go in, and FYI, there's not actually threads being created there. It's just smaller at the bottom, the hole here, as opposed to the orange part here, the top part actually is a bigger hole because it needs the head of the screw to go into it. So the bottom part here is not, but essentially you go between different settings for fasteners and thread diameters and things like that. So all customizable here. And then if we go into the ribs tab here, right now it's not creating any ribs, but if we click the check mark for it, it'll create the top ribs. And if we click slide 2 for it, it'll create the bottom ribs. And I prefer the curved fillet fins for my ribs. It just looks nicer. So then it has more support if it needs it. If it makes more sense if it was maybe at the center of the model, because at the corner here already has a good amount of support, but that's what the ribs here are here for. So I can go ahead and select through. And let me hide the top part here. Now we have, it even came with the screws that are being referenced. Fusion 360 does connect to McMaster-Carr, so you can insert McMaster-Carr components directly through this tool here under insert. But so these are some hardware that it just comes into it, so you know which ones to use to be threaded into here. And if I hide these, if we take a look inside of here, it's not threaded. You'd have to it essentially taps itself when you screw it in. I have the model here. I'll be showing in just a moment, the 3D printed model. It's very hard to see because it's a lot smaller than I anticipated, but you can utilize, or it doesn't come threaded is what I'm saying. And then if I show the top part here, you can see that this hole's bigger, like I was mentioning, for the screw to go in, and that bottom hole there is smaller because that's where the thread will go in. And you can always flip that upside down in the tool here, like we can with the snap fits, so then you can make the bigger hole at the bottom instead. All right, and then let me go ahead and stop my share, and then I'll share my screen again, or share my this screen here. Thank you. So here's the one with the bigger hole on top. It's gonna be a lot harder to see. There you go. And then this one is with the smaller holes on the bottom. And then they would go in together like this. There's no hole at the bottom here, but there are holes for the top there for the screw to go in. I haven't gotten around to finding the right size screw, to be honest, so that's why it's not completely screwed together. But that's what it looks like 3D printed. And yeah, I did check to see there were no threaded holes in the slot here. All right, but the ribs came out fine and everything else came out fine, so I just need to find the right screw for that. All right, that's it. I will go back to the tips and best practices, but at this time I'll go ahead and open up the floor for questions. I'm also going to post this link in our chat room that we have going here, so you can see another video and some just small tips here and there that someone else has done for utilizing the snap fit features inside of Fusion 360. So let's go ahead and put this in the chat room. I appreciate, thank you, Zoe, for translating that over to everyone. But that's just a link for more information on this. And we do have a survey that will be going out just to get feedback from everyone. So definitely fill that out after we end this webinar here, just so we can better improve ourselves here at KETIV Technologies. All right, I do see a question come in. How does this compare to doing it in Inventor? Is it more efficient? I haven't played around with the snap fit functionality inside of Inventor, so I can't give you a direct answer on that, unfortunately. It's pretty efficient, as I can see here inside of Fusion. And to be honest, I'm curious about the flex options, or if it's even an additional flex option to have to purchase that in Inventor. So that would be interesting. I can get back to you on that answer for sure. All right. I don't see any other questions coming in. So if not, reach out to me, brian.mongkolpoonsuk@ketiv.com. Maybe you could find my last name through another or through Zoom right here. If you have questions later on, or if you're going through the process yourself, let me know and I can help you out with that. All right. With that said, I do appreciate everyone's time again, and thank you for hopping on, and I'll see you at the next one.